Hello everyone. So welcome to you all in this discussion. So today we are going to talk about the questions, multiple choice question from unit and dimension. So I have brought here a few questions which are useful for medical and engineering entrance preparation. Similarly, this will be very useful to understand the key ideas of unit and dimension. So let's begin the discussion from here. And here we are going to start from the question number 1. This question says that for two different physical quantities A and B, which of the following operation are valid? Okay, so here the first is the quotient of A and B, sum of A and B, difference of A and B, and all. These are the four options. So we need to be very careful about the operations of physical quantities. So let us examine, let us utilize the idea of elimination. So in here, this is the sum. So you know very well, in case of sum, we can add two physical quantities if they are of same unit or same dimension, like velocity can be summed with velocity, and velocity cannot be summed with acceleration. So this option is going to be ruled out. That's why sum is not possible. This operation is not possible. Similarly, the difference is negative sum. That's why, again, this operation is also not valid for this particular case. And obviously, the all will not be the possible answer. That's why our possible answer will be the quotient of A and B. And you know very well, if you have like a meter and if you have a second, then we can take the quotient of meter and second for velocity. So the quotient of these two physical quantity can give rise into new physical quantity. That's why the correct answer is A by B. Similarly, let us look at the second question. For Planck constant h, velocity of light c in vacuum is c, and the universal gravitational constant is g. Which of the following uh, poses the dimension of length? So we have given here some quantities. So hg, c to the power 3 by 2, c to the power 5 by 2, sc, and these all. So you are much familiar from the general calculation, that is, we have to get the unit of length. So unit of length, utilize the concept of homogeneity. So length is m0 l t0, and let's say h power a, c power b, and g power c. And let us utilize the dimension of this h. So your h is like your ml t power minus 1. So why it is mlt minus 1 is we know E equals to h nu, and your h equals to E by nu. So E by nu means this is your m l t minus 1 to the power a, and the velocity is m l minus 1 to the power b, and g means obviously m power minus 1, l power minus 3, and t power minus 1. So if we are utilizing this to c, then you can easily obtain the value of m0, l1, and t0. So just utilize the concept of homogeneity. You are going to get a equals to b will be equals to 1 by 2, and the c will be equals to 3 by 2 with a negative. So if you just substitute these values, then your correct answer is going to be Hg c power 3 by 2, Hg with root c power 3 by 2. So this is how we can easily obtain the answer for this question number 2. Let us move on to question number 3. This is quite similar to question number B, and this is related with if n denotes the positive integer, as denotes Planck constant, q the charge, and v the magnetic field, then the quantity ns 2 pi by qb has a dimension of. So we have to carry out the calculation for this nh and this 2 pi doesn't have any dimension. This is purely a number. That's why we have to get the idea of this. N is a pure number again. So add say Q and B. So if you are familiar with the motion of electron or charged particle inside electric field and magnetic field, probably you can utilize this concept. That is, MVR will always be equals to NS by 2 pi. This is the Bohr criterion. And another we are familiar with is mv square by r equals to bqv for particle moving inside the magnetic field. So if you just look at this information, ns by 2 pi, ns by 2 pi comes from here. And if you just cancel out this v and you just arrange it, you will be getting bq equals to mv by r. So if you just substitute that this is ns by 2 pi and bq, for this you can simply utilize this mv r by mv r. So this will cancel out and it comes simply r squared. So r squared means the dimension of mirror square. That's why the answer is again area. Okay, so let us move on to question number 4. This is again related to the ratio of physical quantities, and let's crack this again. And the ratio of Planck constant and that of moment of inertia has a dimension of. Okay, so we are familiar with the information of this. E equals to h nu, so h will be equals to E by nu. That's why the dimension of this Planck constant, okay, dimension of this Planck constant is going to be m L to power t minus 1. Okay, so E by S nu. So this is going to be this much. And again, we are familiar with the moment of inertia is m L square. So if we just take the quotient of these two, then we are going to simply get the dimension of 1 by t, and this 1 by t is per time is related to frequency. The answer for this particular question is going to be frequency. Okay, so now let us move on to another question. So here finally we have the last question for today. Okay, so the dimension of mu naught epsilon naught to a power negative half. Okay, so we are familiar with this parameters. This is permeability and this one is permittivity. And if we take the product of permeability and permittivity, this is going to be related to velocity of light. Okay, so we can simply write this mu naught epsilon naught to a power half as 1 by mu naught epsilon naught squared. And this is our under root of c, velocity of light. Okay, so we can simply get 1 by c of 1 by c. Okay, this is our 1 by c, and if we are just taking this quantity, this comes out as a c. Okay, so the velocity is simply a measure for time. Okay, so simply meter per time. So the correct option is going to be length and time in here. So this is our correct option. So this is how we will complete the discussion for today. Thank you all. Just stay tuned. We will be coming with other questions of other chapter in next session. Thank you all.